Okay, let's try and multiply some more of these complex numbers, but the problem here is that this doesn't look like a complex number, does it? We need to simplify the radical first. So remember, your square root is going to come to the end as an I. The square root of 25 is 5, and then we have our I, times the square root of negative 4. Well, the square root of 4 would be 2, and because there's an I underneath the square root, a negative, that becomes an I. Now when we multiply 5i times 2i, we get 10i squared. But now we can never ever leave I squared because we know what that is. That is technically a negative 1. So 10 times negative 1 would be negative 10. This is what it simplifies to. Okay, here we have another binomial, but again, notice that we have a square root of negative numbers. So the square root of 16 would be 4, and then because we have the negative in there, we'd also have the I. So that's how that simplifies. Now let's do the square root of negative 4. Well, the square root of 4 would be 2, and then because it was negative, we have to put the I in there. Now we distribute. So we're going to distribute the 2. So 2 times 1 would be 2. 2 times negative 2i would be minus 4i. And then we'd have to distribute our 4i also. 4i times 1 would be positive 4i. And then positive 4i times negative 2i would be negative 8i squared. Now, looking at these two, do we notice that the minus 4i and the plus 4i will cancel each other out? Absolutely. And we know that I squared is negative 1, which makes this entire term here, negative 8 times negative 1, is actually going to be a positive 8. So when we collect our like items, we have a positive 2 and a positive 8, which is a positive 10 as our answer.